or homework for presentation.
Key findings from redox-driven mineral and organic associations in the crater. Organic matter and redox reactions. Organic carbon was detected in mudstones at several targets: Apollo Temple, the Walhalla Glades. This organic matter appears to have participated in low-temperature redox reactions, forming iron phosphate and iron sulfide minerals. These reactions occurred post-deposition, suggesting autogenic mineral formation formed in place and not transported. The mineralogical associations, nodules and reactions fronts enriched in iron phosphate and sulfur were found consistent with vivianite and greigite. The PIXL and Sherlock instruments identified these features and their elemental compositions. The iron phosphate nodules are not sorted or layered, supporting their formation. The geological context: the Bright Angel Formation lies stratigraphically above the margin unit, but may be part of an older unit. It includes mudstones, conglomerates, and coarse-grained lithologies indicating varied depositional environments. The formation shows signs of chemical weathering, oxidation, unlike the more anoxic western fan sediments. Number 4, we have spectral and textural evidence. Data show differences in iron 3+ content and hydration levels across targets. Apollo Temple had the strongest organic signal and highest vivianite plus greigite content. The Malgasa crest showed no organic matter and lowest redox mineral abundance. Number 5 is the implications for Mars habitability. The presence of organic matter and redox-active minerals in low-temperature settings strengthens the case for potential habitability. These findings support the idea that the crater hosted environments capable of preserving biosignatures. And this is our graph for the key findings. The Perseverance rover explored the Bright Angel Formation in the crater to investigate Martian habitability and geological history. It also detected organic matter and potential biosignatures, and to collect samples for future Earth-based analysis. The organic matter detected in mudstones. So our finding was that the organic carbon was found in fine-grained mudstones at targets. The technique of the Sherlock instruments identified the band at 1600 centimeter as spectral signature of organic carbon. The significance suggests post-depositional redox reactions involving organic matter potential biosignature relevance. And the second point is that the formation of iron phosphate and iron sulfide nodules. Our finding was that the nodules enriched in iron phosphate and sulfur were observed, inconsistent with minerals like vivianite and greigite. The significance is that these nodules formed in after sediment deposition, indicating low temperature redox processes potentially involving organic matter.
Our third finding, being textural and mineralogical diversity, the finding was that bright angel rocks show layering, nodules, veins, and conglomerates with varied mineralogy. The significance indicates complex depositional environments and diagenetic history with implications for fluid flow and habitability.
The findings from redox relationships between organic and minerals would be the correlation between organic and abundance of vivinite and greigite, with Apollo temple showing the strongest signal. The significance of this is that it suggests that organic matter may have driven redox reactions, forming iron-bearing minerals, key to understanding geochemistry and potential life. The observed association where organic matter is closely linked to reduced iron and sulfur minerals is a common biosignature found in terrestrial sedimentary environment. Key findings from this section. Key finding number one would be organic as a reductant. The presence of organic carbon suggests that it may have acted as a reducing agent. Organic matter could have driven the reduction of iron 3 and iron 2, enabling the ferrous phosphate and ferrous sulfide. Key finding number two is formation of vivinite and greigite. PIXL element data shows nodules with iron P ratios consist with vivinite. Sulfur-rich zones with iron and iron sulfate ratio. These minerals likely formed in stew, not transported based on the distribution and lack of sorting. Key finding number three is redox gradates and reactions fronts. The nodules and reaction fronts are chemically distant from surrounding mudstones. Element mobility patterns suggest localized reduction. These fronts may represent zones where iron sulfur phosphate were reduced and precipitated. Key finding number four would be low temperatures, aqueous conditions. The mineral assemblage and lack of recrystallizations indicate low temperature diagenesis, where water rock conditions potentially inhabitable. Potentially habitable. Key finding number five will be implications of biosignature preservations. The co-location of organic matter with redox-sensitive minerals like uranite and greigite is significant. On Earth, such associations often microbial environments, raising the possibility for big processes. However, abiotic pathways are also plausible, and further analysis of return samples on Earth is needed to resolve this.
Key finding number six is coexistence, and transport. Iron phosphate enriched masses aren't associated with Al2O3, suggesting the coexistence of aluminum phosphate minerals typical of transport of Al3 plus and Fe3 plus under oxidizing low pH conditions like variscite and stringite. The transportation of the following elements most likely occurred under non-oxidizing conditions which, when combined with moderate pH, prevented mobilization. Conditions such as these favored the precipitation of vivinite.
Key finding number seven is localized chemical changes and reaction fronts. The PIXL mapping showed zones where iron, phosphorus, and sulfur were enriched compared to surrounding mudstone. Magnesium, aluminum, and silicon were depleted, evidence of element movement during aqueous alterations. These reaction fronts mark boundaries where oxidation reduction reactions occurred, linking organic carbon with mineral formations. The spatial organization of these zones indicate closed system degenesis, meaning the chemistry involved locally rather than by large-scale fluid flow.
And keep finding number eight, reaction mechanisms. Chemical and sedimentological data show that reduced iron and sulfur were generated, mobilized, and precipitated after the deposition of fine-grained oxidized iron and phosphorus-bearing sediment. Phosphate is not associated with the mineral phase except when found in authigenic nodules and reaction front rims. During deposition, phosphate was absorbed on Fe3 plus Al and Si-rich sediment grains. Iron and phosphate have been redistributed into authogenic nodules and reaction front rims in the bright angel area. Mass balance calculations suggest closed system reorganization of these chemical compounds into vivinite.